Hey there, fellow space explorers. Welcome to the Deep Dive, where we take a deep dive into all sorts of fascinating topics. Before we get started, make sure you hit that like button, subscribe to our channel, and ding that notification bell so you don't miss out on our future cosmic adventures.
Sounds good.
Today, we're turning our attention to something that's been with us since, well, forever, the sun.
It's not just some bright light in the sky. It's a giant churning ball of plasma, a
Right.
star that holds, the secrets to our very existence and shapes the entire fabric of our solar system.
Absolutely. And whether you're prepping for the UPSC geography section or maybe brushing up on astronomy for school, or even if you're just curious about the universe, we've got you covered.
Right.
We're going to break down the sun's structure, all its fiery activities, and its huge impact on Earth. Consider this your crash course in solar science.
A solar science crash course. Love it. Let's start our journey right at the heart of the sun, its core. Imagine a place where the temperature soars to 15 million degrees Celsius.
15 million degrees? Wow. That's hot enough to fuse hydrogen atoms into helium and release unimaginable amounts of energy.
You got it. And it's this fusion process that fuels the sun, providing the light and heat that bathe our planet. But it's more than just energy production. This fusion is also the birthplace of the elements that make up everything around us. From the oxygen we breathe to the iron in our blood, it all came from stars just like our sun.
That's incredible. So the carbon in my pencil, the nitrogen in the air I breathe, all forged in the heart of a star. Mind-blowing.
It is pretty amazing.
So how does all this energy make its way from the core all the way out to us millions of kilometers away?
Think of it like a relay race. The energy passes from one zone to another. First, the energy travels outwards from the core through a process we call radiation.
Okay, so picture like light rays traveling through space. But I imagine the sun's interior isn't just empty space, right?
You're right, it's actually quite dense. As this energy moves through the radiative zone, it gets bounced around, absorbed, and re-emitted, making its journey quite slow and complex.
Like navigating a crowded room, bumping into everyone on the way.
Exactly. And eventually, the energy reaches a point where radiation isn't the most efficient way to travel. That's where convection takes over. Think of a pot of boiling water. The hot water rises, cools, and sinks back down, creating those churning currents.
So the sun's interior has these like massive churning currents of superheated plasma.
Yeah.
Now, what is plasma exactly?
It's a state of matter where atoms are stripped of some of their electrons, creating a mix of charged particles. It's often considered the fourth state of matter, alongside solids, liquids, and gases. And because it's made of charged particles, plasma is highly responsive to magnetic fields, which play a big role in the sun's behavior.
Okay, so we've got this churning plasma carrying energy outwards. What happens next? Does it just keep going forever?
Well, not quite. Eventually, this energy reaches what we call the sun's surface, the photosphere.
The photosphere, that's what we actually see when we look at the sun, right?
Exactly. It's a relatively thin layer, but it's where most of the sun's visible light is emitted. Now, even though we call it the surface, it's still incredibly hot, about 6,000 degrees Celsius.
6,000 degrees. That's hotter than any furnace on Earth. And I remember learning about sunspots, those darker patches we sometimes see on the sun. Do those happen in the photosphere?
You're right on the mark. Sunspots are cooler regions of the photosphere, and they're fascinating because they're caused by intense magnetic activity. Think of these magnetic fields like giant knots that disrupt the normal flow of heat and energy, creating those cooler, darker patches.
So sunspots are like windows into the sun's complex magnetic field. It's amazing how something seemingly so simple, a dark spot, can tell us so much about what's happening beneath the surface.
Absolutely. And what's even more interesting is that these sunspots aren't static. They actually follow an 11-year cycle, increasing and decreasing in number over time.
So the sun has its own rhythm, its own heartbeat in a way.
That's a great way to put it. But our journey doesn't end at the surface. We need to venture further, beyond the photosphere, into the sun's outer layers, the chromosphere and corona.
Ah, yes. The chromosphere is that reddish layer we see during solar eclipses, and the corona is that wispy white halo. I've always found those images so beautiful and mysterious.
They're captivating, aren't they? The chromosphere is where the temperature starts to rise again, but the corona, the outermost layer, is where things get really wild. We're talking temperatures of millions of degrees Celsius again, even though it's further from the core.
Millions of degrees, but how is that possible? I thought the core was the hottest part.
That's one of the big mysteries scientists are still trying to solve. One theory suggests that energy is being transported and dissipated by waves generated in the sun's interior,
Yeah.
and channeled by the sun's complex magnetic fields.
It's amazing to think that we're still uncovering the secrets of something as fundamental as our own sun.
It's a constant source of fascination and discovery. And speaking of the corona, it's a very active place. It's where we see those dramatic solar flares and coronal mass ejections erupting, sending charged particles hurtling across space.
Now, those sound a bit more intense than sunspots. Are they something we need to worry about here on Earth?
They can have a significant impact, actually. While those charged particles create the beautiful aurora borealis, also known as the northern lights, they can also disrupt satellites, interfere with radio communications, and even cause power outages.
So the sun's activity can have real-world consequences, even at a distance of 150 million kilometers.
Yeah.
It really highlights how interconnected we are with our star, even across vast stretches of space.
It's a reminder that we're part of a larger cosmic system, and understanding the sun is essential for understanding our place within it. Welcome back to our deep dive into the heart of our solar system. We've explored the sun's core, its radiative and convective zones, and reached its surface, the photosphere, where we encountered those fascinating sunspots. But our journey, well, it isn't over yet.
Right. We've got to venture further out, into the sun's atmosphere. I'm ready to unravel more of the sun's mysteries. What's next on our cosmic itinerary?
Let's talk about solar wind, a constant stream of charged particles, mainly electrons and protons, that flow out from the sun in all directions.
Solar wind, it sounds almost peaceful, like a gentle breeze. But I have a feeling it's a bit more intense than that.
You're absolutely right. These particles are traveling at incredible speeds, constantly bombarding planets, asteroids, and everything else in their path.
So it's not just light and heat that we get from the sun. It's also this constant barrage of charged particles. What happens when these particles reach Earth?
That's where things get really interesting. Earth has a magnetic field, a kind of protective shield that deflects most of the solar wind. But some particles manage to sneak through, especially near the poles, and that's what creates the auroras, those breathtaking displays of light in the sky.
Ah, the northern and southern lights. I've always wanted to see those. It's amazing to think that they're caused by, particles from the sun interacting with our atmosphere. But I've also heard that solar wind can be disruptive. Is that true?
It can be. Intense bursts of solar wind can cause geomagnetic storms, which can disrupt satellite communications, interfere with GPS systems, and even cause power outages.
So it's a double-edged sword. Beautiful auroras on one hand, potential technological disruptions on the other. It seems like keeping an eye on the sun's activity is pretty important for us here on Earth.
Absolutely. Understanding and predicting space weather is becoming, well, increasingly crucial as we rely more and more on technology that's vulnerable to these solar storms.
So we've got this constant solar wind blowing out from the sun. But I know there are also more dramatic events, like solar flares. What exactly are those?
Imagine a sudden, intense burst of energy erupting from the sun's surface, like a massive explosion releasing radiation and charged particles into space. That's a solar flare.
Wow, that sounds pretty intense. What triggers these sudden bursts of energy?
It all comes down to those magnetic fields we talked about earlier. Sometimes these magnetic field lines get so twisted and tangled that they snap and reconnect, releasing tremendous amounts of energy in the process.
So it's like a cosmic rubber band snapping. And these solar flares, are they more powerful than the solar wind?
They can be. While solar wind is a constant stream, solar flares are sudden bursts, releasing a huge amount of energy in a short period. They can be incredibly powerful, blasting out radiation that can reach Earth in just minutes.
And I imagine these solar flares can cause even more disruption than solar wind.
That's right. They can interfere with radio communications, damage satellites, and pose a radiation hazard to astronauts in space. In fact, one of the most powerful solar flares ever recorded, the Carrington event of 1859, caused widespread telegraph disruptions and even set some telegraph offices on fire.
Wow, a solar flare setting things on fire here on Earth. That's
Mm.
incredible. It really shows how powerful the sun can be.
And there's another type of solar eruption we need to talk about, coronal mass ejections, or CMEs for short.
CMEs. I've heard about those in the news, usually when they're headed toward Earth. What exactly are they?
Imagine a giant bubble of plasma and magnetic fields being blasted out from the sun's corona, traveling through space at millions of kilometers per hour. That's a CME.
So it's like a massive chunk of the sun's atmosphere being hurled out into space. And I imagine these CMEs can pack quite a punch when they hit Earth.
They certainly can. When a CME hits Earth's magnetic field, it can trigger intense geomagnetic storms, disrupting power grids, satellite communications, and navigation systems. In fact, a powerful CME in 1989 caused a major blackout in Quebec, Canada, leaving millions of people without power for hours.
Wow, it's amazing to think that events happening millions of kilometers away on the sun can have such a profound impact on our lives here on Earth.
It highlights how interconnected we are with our star and the importance of understanding its dynamics.
So we've talked about solar wind, solar flares, and CMEs. It seems like the sun is a pretty lively and unpredictable place.
It definitely keeps us on our toes. And there's one more key feature we need to discuss: sunspots.
Sunspots, we touched on them earlier, but I'm eager to learn more about them. What causes these dark patches on the sun's surface?
Yeah.
And are they something we need to worry about?
Remember those intense magnetic fields we talked about? Well, sunspots are regions where these magnetic fields are so strong that they actually inhibit the flow of heat and energy from the sun's interior to the surface.
So they're like magnetic knots that create cooler areas on the photosphere.
Exactly. And even though they appear dark, they're still incredibly hot, just cooler than the surrounding areas.
So sunspots are a bit like looking into the sun's magnetic soul. It's amazing how much information we can glean from these seemingly simple dark patches.
Absolutely. And what's fascinating is that sunspots follow a cycle, increasing and decreasing in number over an approximately 11-year period.
So the sun has its own internal rhythm, its own heartbeat that dictates the number of sunspots we see.
That's right. And this sunspot cycle is closely linked to the sun's overall magnetic activity, which also influences the frequency and intensity of solar flares and CMEs.
So when there are more sunspots, we're likely to see more solar storms and space weather events.
That's a good general rule of thumb. More sunspots usually mean more solar activity. However, it's not a perfect correlation. The sun's magnetic field is incredibly complex, and there are still many mysteries we're trying to unravel.
It seems like the more we learn about the sun, the more we realize how much we still don't know.
It's a constant source of fascination and wonder for scientists and anyone, curious about the universe. But let's shift gears a bit and talk about how this incredible ball of fire affects us here on Earth.
Okay, let's bring it back down to Earth. I'm ready to hear more about the sun's impact on our planet. Welcome back to our cosmic journey to the sun. We've explored its fiery heart, its turbulent layers, and its powerful eruptions. It's been a truly enlightening experience.
It has indeed. The sun is a constant source of fascination, revealing new secrets with every observation.
We've talked a lot about the sun's, incredible energy output, all that fusion, those solar flares, and that constant stream of particles. Makes me wonder, is the sun shrinking? Is it using up its fuel at a rapid rate?
That's a great question, and it gets to the heart of the sun's lifespan. While it's true that the sun is constantly converting mass into energy, the amount lost is incredibly tiny compared to its overall mass.
So it's like a giant bonfire that's been burning for billions of years and still has, plenty of fuel left.
Exactly. The sun has enough hydrogen fuel to keep shining for billions of years more. In fact, it's estimated that the sun is about halfway through its main sequence lifespan, which is about 10 billion years.
So we've got about 5 billion years before things start to change dramatically. That's reassuring, I guess.
Reassuring for us, perhaps. But eventually, the sun will run out of hydrogen fuel in its core. When that happens, it will enter a new phase of its life cycle, expanding outward into what we call a red giant.
A red giant. So instead of shrinking, it will actually get bigger.
Much bigger. As the core runs out of hydrogen, it will contract and heat up, causing the outer layers of the sun to expand outward, engulfing the inner planets, including Mercury and Venus.
Whoa, that's a pretty dramatic image. A giant red sun swallowing up planets. What happens to Earth in this scenario?
The fate of Earth is still a topic of debate among scientists.
Yeah.
Some models suggest that Earth might be pushed outward into a wider orbit, escaping the sun's expanding grasp. But other models predict a more dire fate, with Earth being engulfed by the sun's outer layers.
Either way, it's clear that the far future of our solar system will be vastly different from what we see today.
Exactly. It's a reminder that the universe is constantly evolving and changing, and our own sun is no exception.
So we've journeyed from the sun's core to its corona, explored its dynamic activity, and even peered into its distant future. It's been an incredible journey.
It certainly has. The sun is a celestial wonder, a source of life and energy for our planet. Understanding it is not just about satisfying our curiosity. It's also about understanding our place in the cosmos.
Well said. And on that note, we've reached the end of our deep dive into the sun. We hope you've enjoyed the journey as much as we have.
And who knows, perhaps this exploration has sparked a lifelong fascination with the sun and the vast universe it inhabits.
Absolutely. So to our listeners, we encourage you to keep exploring, keep asking questions, and keep looking up at the sky with a newfound sense of wonder. And remember, the sun is just one star among billions in our galaxy. And our galaxy is just one among trillions in the observable universe. There's a whole cosmos out there waiting to be discovered.
Until next time, keep exploring the wonders of the universe.
And don't forget to like this episode, subscribe to our channel for more deep dives into fascinating topics, and hit that notification bell so you don't miss out on our future cosmic adventures. Thanks for joining us.